Y'all ready to begin? All right, boys and girls, in today's lesson that's entitled The Earth Inside Out, we're going to be conquering part 3. Remember, earlier in the week we did part 1, then yesterday we did part 2. Today we're going to be going a little bit deeper into the center of the earth and covering part 3. That is correct. So in today's lesson, you guys are going to get a chance to identify the difference between a solid, a liquid, and a gas. In addition, we're going to be reading and describing about the mantle and the core of the earth. And if you remember or recall, those are some of the layers of the earth, okay? We are also going to be talking about the word solid. Say that word with me. Solid. Solid is something that we will describe today and we will do some work with today. All right? Capiche, capiche? Capiche. All of this will help you with identifying the different layers of the what? Of the earth. Thank you for listening. Before we begin today, I want to go over some vocabulary that you will need in your sweet little brains as we are learning about the different layers of earth. The very first word is erupts. Say that with me. Erupts. If something erupts, it's oftentimes used with the word volcano. So when something erupts or a volcano erupts, it sends out what we call lava, ash, and gas all of a sudden in a sudden explosion. If I were to use the word in a sentence, I might say, when a volcano erupts, it's a sudden explosion that sends out lava, ash, and gas. So when we recall that word today, we're going to say erupts. Do that with me. Erupts. So our first vocabulary word is what? Erupts. Very good. The next one is going to be kind of hard to dictate, but it's the word liquid. Say that word with me. Liquid. Very good. A liquid is something that does not keep its shape. Instead, it takes on the shape of its container. If I were to use that in a sentence, I might say, there is a liquid rock deep inside the earth. Say that word with me, liquid. Liquid. Now I want you to do this with me. Say liquid. 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 All right, so the first word was what? Erupts. Erupts. And our new word is? Liquid. Liquid. Good for you. All right, the next one is molten. Say molten. Molten. Molten, sorry guys, is a way to say something that is melted, okay? So oftentimes when we're doing our shaking our wiggles out, we have that one little part where we say, I have to melt my wiggles out. Instead of saying melt, we're going to say molten. Say molten. Molten. If I were to use molten in a sentence, I might say, it takes very high temperatures to melt metals into molten forms. So I want you to pretend to melt your body. Say molten. All right, so our first vocabulary word was what? Erupts. Very good. Next one was? Liquid. And the next one is molten. Very good. All right. The next word is the word solid. Say solid. Solid. Solid is an adjective, and it is a word that describes anything that is hard or takes its shape. For example, if I were to use this word in a sentence, I might say, they put the water in the freezer so that it would become solid ice. The word is solid. Say that with me. Say solid. Solid. I want you to make your body solid. Can you do that? You're taking on the shape of your body and you're holding it hard and still. Say solid. All right, so first word was? Erupts. Second word was? Liquid. Third word was molten. Very good. And then next one is solid. Nice and hard and still is solid. All right, so the next word that I want to introduce to you is the word that I used previously. It's called volcano. Say volcano. Volcano. A volcano, boys and girls, is a mountain that forms over a crack in the earth's crust, which comes from lava, ash, gas, and fire erupting from it. Okay? Capiche, capiche? If I were to use this in a sentence, I might say, in order to study the volcano, the scientists had to climb from the bottom of the volcano to the very top. The word is volcano. Say volcano. Volcano. Now, this time, when you say volcano, I want you to make like a triangular form so that it looks like a mountaintop. And I want you to shake it just like this. Because what's going to come out of that volcano? Lava. And instead of saying coming out of the volcano, we're going to say erupt. All right, so first word was erupt. Very good. Second word was liquid. Third word was molten. Very good. Next word was solid. Nice and strong and hard, taking on that shape. And the last word was volcano. Are you ready to begin? All right, so now that we have gone over those vocabulary words together, I want to take a minute to go back and access some of the things that we've already learned in our lesson, okay? This is a what? It's a globe. That's right. This is our globe. And what is it that's identified by the star at the top? What do we call that, Diana? The North Pole is correct. And what is identified with the star at the bottom? Emma? The South Pole. What is the imaginary line that equally divides the top half of our Earth and the bottom half of our Earth? Raina? The equator, that is correct. Now, one of the things that we've also been talking about is the landforms that are on the globe. Do you remember that word that we use to describe or recall what the landforms are? What are the landforms, Cooper? Continents. They are. They're continents. Kiss your brain. That's absolutely correct because we've been struggling with that word. Everybody say that with me. Say continents. Continents. Remember that song we sang when we said, the name of my continent is North America, North America, North America. The name of my continent is North America. That's the name of my continent. Very good. Now, what are all of those blue? What's shaded as blue? What's the objects that are shaded as blue, which the Earth is mostly covered with? Zane?
The ocean.
The ocean. Very good. All right. So now I want to challenge you a little bit further. We talked about one of the layers of the Earth, and I'll show you the diagram here. Anybody recall what this outside layer of the Earth is called? What is the outside layer of the Earth? Tell me.
The out crust.
It's called the crust. Good job. I love how you did this before you did this. This is known as the crust. All right. Do you guys remember what the next layer is? What's the next layer, Will?
Outer crust?
Not quite.
Inner crust.
Not quite. Think again. It's right below the crust. What's it called, Zane? No. Something that starts with a mm. Mm.
The mantle.
You are so close. It's the mantle. Yes, it's the mantle. Now, does anybody remember or recall what this is? Desiree?
Outer crust?
Not the outer crust, but
Inner
you were correct when you said outer. You were partially correct. It's the outer core. And what's the middle section called? Anna? Athena, sorry.
The inner.
The inner what? Not the inner crust. The inner what, Anna?
Core.
The inner core. Very good. All right. Which layer of the Earth do we live on? Which layer of the Earth do we live on? Cohen. The outside. What's the outside called? The crust. Very good. Shout it. Don't doubt it. That was absolutely correct. All right. Remember, the crust is where geologists look to learn about the history of the what? Of the Earth. The many layers of rock found in the crust can teach us about different periods of time in the history of Earth. Remember, we talked about 3 things that affect change in the Earth. Does anyone recall what those 3 things were? It's something that Jerry the geologist told us that we really needed to remember. What was it, Raina?
Heat, pressure, and time.
You remember what we did? Heat, pressure, time. That's right. All of those 3 things are going to be important today as we learn about the other layers of the earth, okay? Anybody recall or remember why the heat, the pressure, and the time is so important when we're studying the earth? Zane, tell us.
It tells us more about the earth.
Yes, but what specifically does it tell us about the earth? Tell me.
Rocks.
Not quite, but you're getting closer. Lila?
It might tell the people on earth if there's going to be a volcano erupt.
That would probably be a great indication, but I'm looking for something different. All of those things, heat, pressure, and time, dictate the changes in our earth, okay? Do you remember that part?
Yes, ma'am.
All right, so the things on earth can be described in 3 different ways, okay? One of the ways is what we call a solid. Take a look at this book here. This book is considered a solid, okay? The reason why, Will, it's considered a solid is because it takes on the shape of the book. No matter what I do to it, if I drop the book, if I wiggle the book, if I toss the book, the shape is still going to be the same, okay? Can you think of any other things that might be examples of solids? Tell me something else that might be a solid. A rock would be a solid because no matter what, if you drop it, toss it, flip it, it's still going to take the same shape of the rock. Very good. Tell me another one. The board would be a solid. Cameron?
The moon.
I'm not quite sure that the moon would be a solid. Think about that one again.
Our heads.
Our heads are definitely solid.
No.
You're right about that one. All right, Cohen?
Our skull.
Our skull for sure. Give me something different that doesn't name a body part. What about what you're wearing? What is this?
Glasses.
Your glasses are considered a solid. Now, boys and girls, hands down, I love the answers that you're sharing, but I want to talk about the different form of what we call matter. It's called a liquid. Can you say liquid?
Liquid.
Now, I brought a few things here to share with you to show you. This cup, what would it be considered?
Plastic.
Well, it is plastic, but it's considered a solid. Now, a liquid is something that flows and changes shape depending upon its container. Now, this bottle, what would this bottle be considered? A solid. However, when I pour this liquid into this cup, it now has a different shape than it did before, okay? So a liquid is something that can be poured and it takes on the shape of its container. This container is a what?
Solid.
A solid. It's a bottle, right? But this container is a what?
Liquid.
Not quite. What's the container? It's a cup, right? But what's inside the container is a liquid. Yes, because it's something that can be poured. Can you think of another type of liquid? What's another type of liquid? Someone new. What's another type of liquid? Cohen, tell me another type of liquid. Kool-Aid, yes. That's a yummy liquid. Tell me another type of liquid. Emma? Fanta, orange Fanta that you drink would be a liquid. Tell me another kind of liquid. Milk is actually a liquid, yes. One more. Snow. Well, when the snow melts, it becomes a what? It becomes a liquid, yes. All right, hands down. Now, the other form of matter that we talked about, so we talked about solid, liquid, and the last one is called a gas. Can you say gas? Now, the gas is often hard to describe, but I'm going to do my best to use this balloon to describe what a gas is, okay? So, Take a look at this balloon. What do you think the balloon is considered?
A solid.
It is a solid. But watch what I'm putting in the balloon.
Gas? Air.
Can you see what's inside that balloon?
Gas.
No. A gas is often something that you cannot see, okay?
Smoke.
Gas is considered to be something like carbon dioxide or the oxygen that we breathe. That would be considered a gas. Capiche, capiche?
Going down.
Capiche, capiche? Now, sometimes you may have a solid. Do you see the solid that I have here in the bag? But when you have the solid, what is the solid that I have here in the bag? What's the solid I have here, Ethan?
Ice.
It is ice, that's right. Sometimes when you have a solid, heat can allow it to change from a solid to a liquid. And you'll notice here, and I'll pass it around quickly so everyone can see it, this solid is changing into a liquid because it's no longer in the very cold temperatures. Because we have brought the ice out into heat, it's changing into a liquid, okay? All right, so are you guys ready to learn a little more about the layers of the earth?
Yes, ma'am.
All right, pass it quickly.
So it doesn't melt.
Well, it's going to continue to melt as long as we have the heat, right? Because heat, pressure, and what? Time can affect the change, okay? That is a solid. Thank you, friend. All right. Here are the layers of the what? Of the earth. Today we're going to pretend that we can journey deep, deep, deep inside the layers of the what? All the way to the very center, nearly 4,000 miles from where we are sitting right now. The first stop is the layer beneath the crust. Earlier today we called it the mantle. All right? The mantle is a whopping 1,800 miles thick, and it contains mostly rock. Boys and girls, if you want to imagine what 1,800 miles is, here is a state called Colorado, right? And the distance from Colorado, that's right, because you traveled there not long ago, but the distance from Colorado all the way to New York would measure how deep it is to get into the mantle of the earth. 1,800 miles deep, okay? Because most of the earth is made of rock, that means most of the earth is contained within the mantle. The mantle is mostly made of solid rock. The closer to the crust, the cooler and harder the mantle tends to be. But as you go deeper, closer and closer to the core, the mantle gets hotter and hotter, and it becomes soft and gooey. Heat closer to the core causes the rock inside the mantle to move around quite a bit. But in most places, it is solid rather than liquid. Did you hear that word heat again?
Yes.
All right. Heat causes parts of the mantle to move around. Remember, something that is solid keeps its what? Keeps its shape. While something that is liquid can move around a lot and take on the shape of whatever it is in. The mantle surrounds the core, or the center of the earth. The core has two parts. It has the inner core and it has the outer core. The inner core is a solid metal ball. The outer core is also metal, but guess what? It's not solid. It's made up of melted or molten metal, Okay, remember, if the metal is molten, that means the heat has changed it from a solid to a liquid. This means that deep down inside the earth, thousands of miles beneath our feet, there is a giant sea of red, hot, molten metal surrounding a solid metal ball. So, let me see if we're understanding what we're reading. What does it mean if the inner core is solid? What does it mean if the inner core is solid, Diana? Yes, it's maintaining its shape. It's holding its shape. I love the way you describe that. Scientists believe that the very center of the earth, which is right here, the very center of the earth, the inner core, is actually hotter than the surface of the sun, which is a blazing 10,000 Fahrenheit. Now, let me show you what that number looks like. If I were to write the number 10,000, thank you, friend. Here's what it would look like. Well, this number is a little less than how old the earth is. Remember, how old the earth is 4 billion. So that's the billionths place. But watch, 10,000 Fahrenheit is how hot it is, okay? Now, on a typical hot, sunny day, a really hot day on earth, it's only 100 degrees. Can you tell the difference in between those two numbers? Yeah, so this describes how hot the inner core is, okay? Capiche, capiche? All right, let's keep reading. The inner core is much hotter than the outer core. It may seem strange, therefore, that the outer core of the earth is molten metal, yet the inner core at the very center of the earth, where it's the hottest, is a solid ball of metal, which, by the way, is just a bit smaller than the moon. The reason that the inner core is solid has to do with the incredible pressure of the earth's entire weight pressing inward. The more pressure you put on something, the more heat you need to cause that thing to boil or melt. This is why the metal at the very center of the earth, the inner core, is solid instead of a liquid. Despite the intense heat, boys and girls, there is simply too much pressure caused by the weight of the rest of the earth. So the center of the earth cannot melt, and it remains solid. Did you hear that word pressure again?
Yes, ma'am. Yes.
Pressure causes the inner core to be solid rather than liquid. Thank you for listening. Let's turn the page. Take a look at this image here. The crust upon which we live is constantly being changed and reshaped due to heat and pressure caused by activity in the Earth's mantle and core. Did you hear that word heat again?
Yes.
Did you hear the word pressure again?
Yes.
Heat and pressure in the Earth's mantle changes the Earth's crust. The San Bernardino Mountains that you see in this picture here, along with many other mountains along the west coast of North America, from Mexico all the way to Alaska, were created by the changes inside the earth. Now, remember that word volcano that we talked about earlier? Here is an image of the volcano.
Is that a real word?
Well, actually, it's not a real one, but it's an illustration. Good question. Remember the parts of the mantle that are the closest to the core? Remember we said those are the ones that are soft and gooey? That hot, gooey material in the mantle always stays in the mantle. Sometimes it rises to the top of the surface. Often, some of the extremely hot molten rock or magma pushes up through the mantle and it forces its way into the cracks and the crevices of the crust. Over time, the magma collects in a magma chamber, such as the one near the bottom of the picture. See the chamber there? This is what they're talking about when they talk about the chamber. Over time, the magma collects in a magma chamber, such as the one near the bottom of the picture. The heat in the magma chamber releases gas from the magma, which builds up and up and up, and it creates what we call what?
Volcano.
What's that term we
Pressure.
talked about? Pressure. The pressure builds and builds and builds until one day, boom! Did you hear the words heat and pressure again?
Yes.
Heat and pressure are causing the volcano to erupt. The magma erupts in a volcano of lava, ash, gas, and fire. Once it's released from the earth, the magma becomes lava, flowing liquid rock, which flows across the ground until it cools and hardens into a solid rock once again. The eruption of lava, boys and girls, is ash, gas, and fire, which forms the volcano. All right, you ready to learn a little more?
Yes.
All right, image of a real volcano. So the last image was an illustration, but this is a real photograph, okay? What do you see in the picture again?
Lava.
Well, we see lava. What else do we see?
We see a sunset.
We see a sunset.
A volcano.
And a volcano. Now that I have told you about volcanoes, let me explain one more thing. Thanks to geologists, we have a pretty good idea when and where the geologic events are likely to occur. Geologists help predict where volcanoes are most likely to occur, and this helps keep people safe by discouraging them from building homes close to the dangerous areas. It is not always possible to predict when and where geologic disasters will occur, but geologists work hard to give people as much warning as they can. Disasters, boys and girls, is a term that's used to describe sudden events that cause a lot of damage, okay? So if I were to help you make a text-to-self connection there, I might think about the tornadoes that we once had. That is considered a disaster, okay? Yes, Cooper. Have you really? That's called making a text-to-world connection. Thank you for sharing, friend. All right, let's go over some things that we've learned from the reading. And I want to see if I can jog your memory and see how much you have learned during this lesson. Are you ready?
Yes.
All right, what are the names of the layers of the earth? What are the names of the layers of the earth? Give me one, Anna.
The inner crust.
Not the inner crust, but inner is one of the words that we will use. What's one of the layers, Diana? The inner core, yes. Zane? The crust. Cohen? The outer core. One more. Raina? The mantle. Good job. Thank you for doing this before doing this. Next question. Who can describe the mantle? Who can describe the mantle? What's a word or phrase that we could use to describe the mantle? Tell me. That's okay. Who can describe the mantle? Raina, give us some information about the mantle.
The clay.
Say it again.
The clay.
Not quite. Keep thinking though. Zane?
It's wet. It's kind of feels like some clay.
Okay. Not quite like clay. In the image that you see here, it is red, but that red is to help you to remember or recall the fact that the mantle is very hot. It contains most of the Earth's rock, and it gets hotter and softer as it gets closer and closer to the core, okay? All right, now, who can describe the outer core? the outer core? Who can describe the outer core? I'm seeing some of the same hands. I'd like to hear from someone different. Who can describe the outer core? Chloe, what can you tell me about the outer core?
The outer core is when you dig in it, it gets hotter and darker, and it gets harder to dig down.
Now, if you were a geologist, you're correct. The more and more you dig into the Earth's surface, it is harder and harder. You're absolutely correct there. But here's what I was looking for. When you think about and you talk about the outer core, boys and girls, I'm hoping you'll remember that the outer core is described as molten metal, right? But what about the inner core? The inner core. How can we describe the inner core? How can we describe the inner core? Tell me.
It's deep down.
Uh-huh.
It's really hard.
It is. It's a solid. It takes on its shape. Good job, friend. It's a solid metal ball. All right. Now, why is the inner core solid rather than liquid? Why is the inner core solid rather than liquid? Tell me what you're thinking.
Because I think it's lava, and the lava can make into rock.
Now remember, the lava is what comes out of a volcano, but we're talking about the different layers of the earth. So tell me, Lila?
Liquid is like softer and kind of like water, and the outer core is hard.
Yes. The inner core is like a solid rather than a liquid. And the reason why it's more like a solid rather than a liquid is because there's just way too much pressure from the weight of the rest of the earth to allow the inner core to melt. What causes the volcano to form? What causes the volcano to form? Zane?
Pressure and heat.
Heat, pressure, and what?
Time.
And time. You remembered. Good. Inside the magma inside the earth makes its way to the surface of the earth, and it causes a volcano to form. Why is it important for scientists to study volcanoes? Why do you think it's important for them to study volcanoes? Desiree, tell me why you think it's so important.
I think it's because sometimes people gotta they're trying to, sometimes people gotta watch out.
Yes.
Volcanoes.
That's definitely one of the reasons why it's so important. She said sometimes people need to watch out for those volcanoes. In the reading, it talked about how they use what they know about volcanoes so that they don't build buildings or places or homes close to the volcanoes because they can't always predict when a volcano will erupt. So they don't want people to be in the way of a disaster. Okay? Yes, ma'am.
Once my dad went in a volcano that had buildings and had stuff in it.
He was close to a volcano. Now you can't go in a volcano because it would be way too hot, but he may have seen a volcano erupt.
And he said at night you could see like the light of the lava.
Okay. Interesting. All right, here's what I'd like for you to do. In just a second, I'm going to ask you to turn and talk to a neighbor, okay? And I want you to think about, thank you for listening first. I want you to think about how the crust, the mantle, and the core of the earth are alike. So you're talking with your neighbor about how the crust, the mantle, and the core of the earth are alike. And then after you talk to your neighbor about how they are alike, I want you to also discuss with your neighbor how they are different, okay? Does everybody hear what Miss Tiffany's asking you to do? All right, who can recall what Miss Tiffany would like for us to talk about with our partner? Zane, tell us what we're going to talk about with our partner.
The mantle and the crust.
What are we going to talk about specifically about the core, the mantle, and the crust? Cohen, help him out.
How they are the same and they're different.
How they're the same and how they're different, how they're alike and different. Please turn and talk to the neighbor at this time. Turn and talk to this group here. Do you guys know what we're talking about? I wanted us to regroup because I'm noticing that some of our friends still did not understand what Miss Tiffany asked of you. So here's what I want to do. I want to go back and revisit the question. The question was, are the layers of the earth alike and how they are different? So think about what you know about the crust. Think about what you know about the mantle. Think about what you know about the inner and the outer core. And I want you to think of something that or some way that they are alike. That means the same. And then I want you to think about a way that they may be different. Okay? Do you think you can do that?
Yes.
All right, so what are we discussing again? Diana?
How the layers are the same and different.
How they're the same and how they're different, okay? And she just gave you a really good clue when she recalled what Miss Tiffany just shared, okay? So turn to your neighbor quickly and let's begin. Different than the first one because I saw more friends who were talking and discussing what they knew and sharing with their partner. One of the things I heard a friend mention was, or one of the things that Diana mentioned that I was impressed with was she said the crust, the mantle, and the inner and outer core are all layers of the earth. That makes them the same because they're all layers of the earth, right? Did you guys remember that?
Yeah.
Yeah, that's the way that they're the same. Now, some of you talked about how they were different, and I heard Lila use a really big word. She said, compare. That means she was thinking about the difference between the two and talking about how they were alike as well. She said, in comparison to the inner core and the outer core, the inner core is a lot hotter, right? Is that what you shared with your friends? And then you talked about the shape of the inner core and the outer core. And then my friend Raina mentioned that as you get closer and closer and closer to the inner core, it gets, what did you say? Hotter and hotter and hotter. Those are the kind of things that I was hoping you would share with your partner. At this time, what I'd like for you to do is we're going to go to our seat and we are going to identify and label the layers of the earth, okay? It's going to require you to have your pencil and your crayons, okay? Capiche, capiche? All right, do that now. If something is solid, remember, boys and girls, it keeps its shape. If I were to use the word solid in a sentence, I might say, it was so cold outside last night that the water puddle became solid ice. The word is what? Solid. Now, let's think about the word solid and let's try to apply what we know about the word solid. I'm going to name an object. If you think that it's something that is solid, say, that is solid. Practice that with me. That is solid. But if it's something that is not solid, say, that is not solid. All right, so your choices are, that is solid or that is not solid. That is solid. A book will always maintain its shape because it's solid. Milk. That's not solid. Water. That is not solid. A desk. That is solid. A shoe. All right, last one. Steam that's coming out of a hot, boiling pot of water.
That is not solid.
That is not solid. Okay, boys and girls, the first thing I want you to do is take out your brown crayon. Take out your brown crayon. Take out your brown crayon. Now, if we use our original diagram that they shared with us throughout the reading, what do you think we're going to use the brown crayon for? Someone besides Zane. Emma, tell me what we're using that brown one for. The crust. Find the crust in the Earth's layers. Find the crust in the Earth's layers, and I want you to color it brown. Find the crust in the Earth's layers, and I want you to color it brown. Now remember, the crust is the only layer of Earth where we live. So think about it. The crust is going to be the outside layer. Then once you've colored the crust, I'd like for you to put your crayon down, pick up your pencil. Let's write the word crust. 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 Very good connection. My friend Zane pointed out that at the very bottom of the page, you have the word crust. Crust. You're going to write that under the word brown. You're going to write the word crust under the word brown. Here are your options below. Find the word crust. No, that's not the mantle. The mantle is the next layer right under the crust. We've got the mantle and the outer core. Take your orange crayon out to illustrate the outer core. Take out your orange crayon to illustrate the outer core. Find your orange crayon. And look, before you do that, let's finish coloring your mantle. Your mantle is there. All right, lastly, don't forget your mantle. Your outer core. You got it. Once you found it, yeah. Right? Now look,